for masonry walls. If you remember, mortar is one of the components of the overall masonry assembly. You have block, grout, and mortar that we all have to be concerned of each one of those different components and their properties. Understanding properties of all of them will help us understand the overall assembly strength. But in this video, we're going to focus on the mortar. Mortar is going to be that paste that's used between blocks or stones to create an overall masonry wall. Mortar is going to become hard when it sets, and just like other concrete products. It's going to be made of a mixture of sand, a binder element such as cement or lime, and water. Mortar is not going to be as strong as the masonry units, and it really doesn't need to be. The purpose of mortar is going to be the glue. It's going to be everything that you're going to see in a masonry wall besides the overall units. And then there's three different types of mortar, three main different types of mortar that we want to be concerned about. When we specify mortar, what we're going to be specifying is mortar to comply with either a proportion method or a properties method. And those two different tables are going to be within the TMS 602 code. It's really important to recognize that you use either the proportion method or the property method. You do not have to meet both requirements. Proportion method simply just gives you the overall mix of the different elements that make up your different mortars. Within the properties method is where you're going to see some strength values being defined. So again, those different types of mortar that we're going to focus on today, the most common different types of mortar in new construction is going to be type M with mortar compressive strength of 2500, type S of a mortar compressive strength of 1800, and type N with a mortar compressive strength of 1000. Again, this is not the overall assembly strength. This is not F prime M. This is just mortar compressive strength properties. The masonry assembly strength F prime M is always going to be greater than the mortar compressive strength. There's a couple different reasons for this. One, when we test the mortar, we're testing it in isolated cubes, which is always going to have a higher water to cement ratio, which always going to yield a lower strength. But also when mortar is placed within a masonry wall, within a masonry assembly, it's going to have an aspect ratio that's going to be wider than it is thick, which yields a higher strength as well. So again, mortar strengths are a property, but not something that is meant to represent the overall strength of masonry. So again, if we look at those different types of mortar, if we go from right to type N, type S to type M, you can see that the mortar compressive strength does increase as we go from right to left. But that's going to be, again, just an aspect of the mortar. It's not going to define the overall strength of the assembly. When we look at the unit strength method that comes from the code, we see that type N mortar does yield a slightly lower strength assembly than a type S mortar. But I think it's really important to recognize that you don't gain more strength when you go from type S to type M according to the unit strength method. Again, this is table 2 within the TMS code. Again, it lumps together both type M and type S mortar. So you can see that we're not gaining more strength by going to that type M mortar. So again, the code's going to look at those two is going to be equivalent to one another. Another important aspect of mortar is going to be the workability. You know, how much the contractors like to use the different types of mortar. And here you're going to see the reverse from left to right. We're going to see it become easier to use. Type N is going to be the easiest mortar to work with. So really, from a structural perspective, type S is going to be something that's both workable and giving us that full strength according to the unit strength method. So that ends up being a very good choice for mortars for structural walls. Again, this is all within the TMS code, table 2 within the TMS code, and then the tables that we created on the bottom right, where we can see different unit strengths put together with type S mortar, giving us an overall F prime M that we're going to use for our designs. So that's going to be the three different types of mortar, type M, type S, and type N. There's also three different categories of mortar. Masonry cement, which is going to be the most commonly used across the country. Mortar, We also have Portland cement lime, which is going to be found in older buildings, still used for historical preservation. And then the less common mortar cement. It was developed by the Masonry Industry Code Committee, really developed for use in higher seismic areas. So if we're going to be designing in any of those areas, we would find more mortar cement, but typically across the United States, masonry cement is going to be the most common category of mortar. We're going to see some of the properties here reflected. Mortar cement a little bit better again for those higher seismic areas. Also, having a higher tensile strength, which makes sense. And then the masonry cement, which is going to be more common, having slightly lower tensile properties. Again, this is going to be important for higher seismic areas, but it'll also be important for an unreinforced masonry system. So again, in summary, what are the different types of mortar that we could specify? Again, type M is high strength, but it's more costly and less workability. Doesn't result in a higher strength when looking at the unit strength method from the code. It can be used below grade, and it certainly can be used in high load applications in extreme environmental conditions. Type S is going to be what we would recommend for structural walls. It can be used in any structural application, both for structural concrete and hollow clay masonry walls. Can be used in all seismic areas and also can be used below grade. Type N is going to be something that I would recommend for a non-structural wall, like a clay masonry veneer or other partition walls. But important elements to note is you're not to use type N mortar below grade, and you're not to use it in seismic design categories D, E, and F. So again, we would recommend type S for the most typical common mortar to use within a masonry system. Again, back to the project drawings, we're going to be specifying each of the components, the block, the grout, and the mortar. We're going to give properties for each of them, but again, for that mortar, we're just going to call out the type. We don't have to define the strength. So again, the most common would be mortar being type S. All of that information can be found in this guide, which is available from that website that you can see on screen. Thank you very much for your time. We'll see you in the next video.